Hello everyone, and in this video we're going to be taking a look at this circumcircle here. Specifically the circumcircle of triangle AEF here, where BE is a foot of the altitude from B to AC, and F is a foot of the altitude from C to AB. And we also let M be the midpoint of BC here. And we're going to go ahead and prove in this video that MF and ME are tangent to this circumcircle here. But before that, we notice that there are right angles here. So we know for one that angle BFC is equal to angle BEC. So BFEC is cyclic. And whenever we see a cyclic quadrilateral, we always ask, where is the center of the circle? And it definitely seems like M is the center here because all of these lengths seem to be equal here. But that directly results from M being the circumcenter of triangle BFC because BFC is a right angle and M is a midpoint. So from here we know that BM is equal to MF is equal to ME is equal to MC. Surely this fact will definitely come in handy when proving that these circles are tangent. So let's go ahead and get into the problem now. So we want to prove that MF is tangent to AEF because then something similar will happen to ME. A very common technique in proving that a line is tangent to a circumcircle is proving that the directed angle MFE, where directed angles are positive if the angles are clockwise and negative otherwise when counterclockwise. We want to prove that is equal to the directed angle FAE, which ends up being, because F lies on line AB and E lies on line AC, the directed angle BAC. So that's what we want to prove. There's no obvious way to compute MFE because even though we know that FME is isosceles, that would involve like computing FME, which would end up becoming like a mess. So we want to somehow use the fact that FM equals MC, and yeah, so what can we do here? Well, we know that angle MFE is equal to directed angle MFC plus directed angle CFE. But this triangle here is isosceles. Now here's where we use the fact that M is a circumcenter. So this ends up being directed angle FCM. And then CFE here ends up being CBE because of the cyclic quadrilateral. Sorry. So we have angle FCM here. We know that it's FCB. However, we know that it's just 90 degrees minus angle CBF because this angle here is 90 degrees, so which means that these angles here add up to 90 degrees. So it is 90 degrees minus directed angle CBF. And then we wish to try doing something similar for CBE here. CBE here. But we also have a right angle here, which means that it's 90 degrees minus directed angle ECB. Therefore, angle MFE is equal to 180 degrees minus angle CBF here ends up being just angle CBA. So directed angle CBA. And then ECB here ends up being just ACB. Directed angle ACB. And we wish to prove that this is equal to directed angle BAC. But this is pretty easy to do because we can just bring these terms to the other side. We get directed angle BAC plus directed angle ACB plus directed angle CBA is equal to 180 degrees. But this is just the angles of a triangle. The sum of the angles of a triangle is 180 degrees. So therefore, we have proven that angle MFE is equal to angle FAE. So MF is tangent to this circumcircle here. And by symmetry, ME is also tangent. So it turns out the tangents from F and E of the circumcircle here meet at the midpoint, which is very surprising. But we are not done there yet, because now we can consider the tangent here at A. Let's go ahead and construct that. Now, what does it look like here? It seems to be tangent to BC. So conjecture is that the tangent at A is parallel to BC. Well, how do we go about proving this? Well, we know that if there's a point X here, then we want to prove, as a similar method from what we did earlier, that directed angle XAE is equal to directed angle AFE. So since XAE is equal to directed angle XAC, and then this ends up being directed angle BCA, because directed angle XAC plus directed angle ACB is equal to 0 degrees. If you're confused about this directed angle stuff, I'll go ahead and put a link inside the description to a nice directed angles handout by Evan Chen, which will make things a lot clearer for you. But anyways, back to the problem. So we see a directed angle XAC. So XAE is equal to directed angle XAC, which ends up being directed angle BCA. So we want to prove that if these two are equal or not. So here we want to try using the fact that FECB is cyclic. So directed angle BCA is equal to directed angle BCE, which is also directed angle BFE. But since A also lines on line BF, it is also directed angle AFE. So we're done. So in this video, we ended up discovering that the tangents at F and E to the circumcircle of triangle AFE here end up meeting at the midpoint of BC, and that the tangent at A is parallel to BC. So thank you so much for watching this video. If you enjoy my style of explaining, then subscribe so you do not miss anything. And I hope you enjoyed the video.